The function f of x is equal to x upon x square minus 6x minus 16 for x belongs to r minus 2 comma 8. Whether this function is decreasing or increasing in what intervals we need to identify. So for this we have to differentiate f dash of x is equal to, by using the rule, u by v whole dash is equal to upon v square v into u dash minus u into v dash. So we can write x square minus 6x minus 16 whole square, and the numerator we can write x square minus 6x minus 16 into differentiation of x is 1 minus, and again x into differentiating the denominator, that is 2x minus 6. So we can write f dash of x is equal to x square minus 6x minus 16 minus 2x square plus 6x upon x square minus 6x minus 16 the whole square. We can write f dash of x is equal to minus x square, and here minus 6x plus x, 6x gets cancelled, and again minus 16 upon x square minus 6x minus 16, we can factorize it. X square minus 6x minus 16, we can write it as x square minus 8x plus 2x minus 16, that is x times of x minus 8 plus 2 times of x minus 8, that is x plus 2 into x minus 8. So we can write in the denominator x plus 2 into x minus 8 whole square. So which can also be written negative of x square plus 16 upon x plus 2 whole square into x minus 8 whole square. So x square plus 16 is always positive, and negative of x square plus 16 is negative, and the denominator x plus 2 whole square into x minus 2 whole square is always greater than 0, and x square plus 16 is an irreducible factor, we cannot factorize it further. So we can write like f dash of x is equal to minus of x square plus 16 upon x plus 2 whole square into x minus 8 whole square is always negative for all real numbers except, we can say, minus 2 and plus 8, because they are in the denominator which cannot be equal to 0, and hence we can say this function is according to the property, if f dash of x is less than 0 in the interval or except minus 2 and 8, it is decreasing. So we can conclude the function f is decreasing on r minus 2 comma 8, or this can also be mentioned on a real line from minus infinity to plus infinity, minus 2 and plus 8, except these 2 points entirely it is decreasing. So we can write x belongs to minus infinity comma minus 2 union minus 2 comma 8 union 8 comma infinity. So we can say that option B is the answer. If R is the smallest equivalence relation on the set 1 comma 2 comma 3 comma 4 such that 1 comma 2 1 comma 2 and 1 comma 3 must be a subset of R, then the number of elements in R can be taken as. So as per the condition, or we know that the smallest equivalence relation smallest equivalence relation defined on set A can be taken as is an identity relation, so which must be containing 1 comma 1, 2 comma 2, 3 comma 3 and 4 comma 4. This is the smallest relation which is satisfying all the three: reflexive, symmetric and transitive. And but here 1 comma 2 and 1 comma 3 is a subset to the real numbers, so compulsory we have to make 1 comma 2 and 1 comma 3 to be belonging to the our relation R. Then if, as per the reflexive condition, for every A belongs to A is related to A. So here 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 is existing. So you can say that it is reflexive whatever the matter if any other elements ordered pairs are added or not added. And coming to the symmetric, if A is related to B, then B must be related to A. So if A is related to B, B related to A. So here 1 comma 2 is belonging to R, then compulsorily we have to take 2 comma 1. 2 comma 1 must belongs to the R, and if 1 comma 3 belongs to R, then 3 comma 1 must belongs to R. So we can say this is now symmetric. And coming to the transitive, if A is related to B and B is related to C, then it's compulsory that A must be related with C. So here we can see that 2 is related with 1 and 1 is related with 3. So 2 must be related with 3. So there should be an ordered pair 2 comma 3 must belonging to the R to make this relation transitive. And remaining all we can say 1 comma 2, 2 comma 1, 1 comma 1 existing, 1 comma 3 and 3 comma 1, 3 comma 1 comma 1 existing. So and also if 2 comma 3 belongs to R, to make the condition symmetric again 3 comma 2 must belongs to R. So that now we can say this relation is completely reflexive, symmetric and transitive. So the number of ordered pairs are the minimum number of ordered pairs here: 1 1 1 2 3 4 5 6 7 8 9 10. So we can consider that number of elements or ordered pairs in R is 10 if 1 comma 2 and 2 comma 3 subset to R. So we can say that option D, 10 is the answer. If the mean and variance of 5 observations are given, 24 upon 5 and 194 upon 25, that is mean x bar is equal to 24 upon 5 and sigma square is a variance 194 upon 25 respectively, and the mean of the first 4 observations is 7 upon 2, then the variance of the first 4 observations is equal to, and we know that the mean is sum of the observations. Let us consider x1, x2, x3, x4 and x5 are the 5 observations, divided by the 5 number is equal to 24 upon 5, which implies the sum of the 5 observations, which is equal to 24, and we want the sum of 4 observations upon the number of observations 4. The mean of first 4 observations is given 7 upon 2, so that we can write x1 plus x2 plus, and here I can multiply and divide with 2, so 4 and 4 gets cancelled here, and so we can write x1 plus x2 plus x3 plus x4 is equal to 7 2s are 14, and if we subtract these both, you will be getting x5 is equal to 10. So we got the fifth observation value is 10. So we got the fifth observation, say x5 is equal to 10. Now let us consider the variance summation xi square upon n minus summation xi upon n whole square, that is mean square, is equal to sigma square. So we can write here x1 square plus x2 square plus x3 square plus x4 square plus x5 square upon n minus the mean is nothing but 24 upon 5 for 5 observations whole square is equal to 194 upon 25, which is given. So we can write x1 square plus x2 square plus x3 square plus x4 square and x5 square, we can write it as 10 square is 100 upon, here it is 5, is equal to 194 upon 25 plus 24 square is 576 upon 25, that is 600, and again 167, 60 plus 10, 770 divided by 25. So we can write x1 square plus x2 square plus x3 square plus x4 square is equal to 770 upon 25 into 5 minus 100. So we can write here 770 minus 500, that is 270 divided by 5, which is 5 5s are 25 and 5 4s are 54. So sum of the squares of 4 observations value is 54. Now variance of first 4 observations, since we have x1 square plus x2 square plus x3 square plus x4 square is equal to 54, and the mean of the 4 observations is equal to 7 by 2. So we can write here sum of the squares, that is 54 divided by n, that is 54 divided by 4 minus mean square, that is 7 by 2 whole square, which is the new variance, that is variance of the first 4 observations. So we can write 54 upon 4 minus 7 square is 49 upon 4, which is equal to 5 upon 4 is the variance of 4 observations. So we can go with an option D. 5 by 4 is the answer. Let A is equal to matrix 2 1 2 6 2 11 3 3 2 and matrix P is equal to 1 2 0 5 0 2 and 7 1 5. Then the sum of the prime factors P inverse into A into P minus 2i is equal to. So here we can write determinant P inverse into A into P minus 2i. Since P inverse is mentioned, let us assume that P is a non-singular matrix, so determinant of P is not equal to 0. So we can rewrite this as P inverse into A into P minus 2 into, here identity matrix we can write it as P inverse into P. And we also know that A into identity matrix is again matrix A. So P inverse into A into P minus 2 into P inverse into identity matrix into P. We can also write this. So from the left side, if I take P inverse common, and the right side if it is taken P is a common, then we have A minus 2i. And we know that the determinant of AB is equal to det A into det B. So we can write here determinant of P inverse into determinant of A minus 2i into determinant of P. And we know the determinant of A inverse is equal to 1 by det A. So we can write here 1 upon determinant of P into determinant of A minus 2i into determinant of P. So we can cancel here determinant of P. So we got finally determinant of A minus 2a. So let us find the matrix A minus 2i, which is equal to 2 1 2 6 2 11 3 3 2 minus 2 times of identity matrix, that is 2 0 0 0 2 0 0 0 2. On simplifying, you will get 2 minus 2, that is 0, 1 minus 0 is 1, 2 minus 0 is 2, 6 minus 0 is 6, 2 minus 2 which is 0 again, 11 minus 0 is 11, 3 minus 0 is 3 and 3 minus 0 is 3 and again 2 minus 2 is 0. So a minus 2i is 0 1 2 6 0 11 and 3 3 0. So let us find its determinant. So determinant of a minus 2i is equal to determinant of 0 1 2 6 0 11 3 3 0, which is equal to 0 times, so you can write minus 1 times of 0 minus 11 3s are 33 and again plus 2 times of 6 3s are 18 minus 0. So we can write 18 2s are 36 plus 33, which is equal to 69. So we got the determinant is equal to 69, but the question is about the sum of the prime factors. So the prime factors of 69, prime factors of 69 can be taken as, so 3 is one prime factor and 23 will be 323s are 69. So 3 and 23 are the prime factors and sum of the prime factors we can write 3 plus 23, which is 26. So the answer is 26, which is option B. Let r and theta respectively the modulus and amplitude of the complex number z, which is equal to 2 minus I times of 2 tan 5 pi by 8. So here we can say that r is equal to modulus mod z and theta is the amplitude of a z or argument of z, and given z is equal to 2 minus I times of 2 tan 5 pi by 8, so which is in the form of x plus iy. So when comparing we can write x is equal to 2 and y is equal to minus 2 tan 5 pi by 8, and we know that r is equal to under root of x square plus y square, so which is equal to root of 2 square plus minus 2 tan 5 pi by 8 whole square, which is equal to root of 2 square is 4 plus 4 times tan square 5 pi by 8, which is equal to 4 taken common 1 plus tan square 5 pi by 8, which is equal to square root of 4 is 2 and again 1 plus tan square theta is secant theta. So secant 5 pi by 8 we can write in the mod. So this is r value. So r can also be written, r is equal to mod 2 secant of 5 pi by 8 we can write pi minus 3 pi by 8, which is equal to 2 times secant of pi minus theta is minus secant theta, so minus secant 3 pi by 8, and since r cannot be positive negative, r cannot be negative, so we'll consider the positive 2 secant 3 pi by 8. So this is value of r, and also we know that tan theta is equal to y upon x. So here we can write tan theta, if theta is an argument, tan theta is equal to y is nothing but 2 tan 5 pi by 8 negative of divided by x is nothing but the real part is 2. So we can write tan theta is equal to minus tan of 5 pi by 8, or we can write tan theta is equal to tan of minus tan of pi minus 3 pi by 8 I can write, which implies tan theta is equal to tan pi minus theta is minus, so minus of minus plus tan 3 pi by 8. So we can consider theta is equal to 3 pi by 8. So the argument or amplitude is 3 pi by 8 and the r value is 2 secant 3 pi by 8. So we can go with an option 2 secant 3 pi by 8 and 3 pi by 8, which is option 2. Option 2 is the answer. Number of ways of arranging 8 identical books into 4 identical shelves where any number of shelves may remain empty. So let us consider in different cases. Case 1, no shelf is empty. Means we need to arrange the 8 books in all the 4 identical shelves. So the possibilities can be taken. Since no shelf is empty, minimum one book can be placed in the 4 shelves, among the 4 shelves. So let us place here 1, 1, 1. So remaining books are 5. And let us take 1, 1, and here it is 2. So here it can be 4. And 1, 1. If I take 3 books here, so remaining can be, so 3 books here. So 1, 1, 3, 3. And again now 1. Now there is no possibility. 4 and 4 we cannot write. So let us choose 2 here. So 1, 2. So that I can write here 3. 1 plus 2, 3. 3 plus 3, 6. 6 plus 2. Remaining 2 element. And the next one. Now there is no possibility of taking again 1 here. So it's completed. So we can go with the next 2 in the first shelf. 2, 2 and 2. So we can't take any number more than this. So again it will be repeated. So 2, 2, 2, 2, only 5 possibilities. So I can say that there are 5 possible ways in which no shelf is empty. And coming to the case 2, let us assume that one shelf is empty. When one shelf is empty, so let us mark the first shelf is empty. Let us not place any of the book. And also you have to make a note that when you are distributing the things here 1, 1, 1, 5, so we cannot arrange them again because they are identical shelves. So only one way you have to express it. So here let us block this first shelf. So we need to arrange the 8 identical books into this 3 shelves. So let us write 1 and 1, so that 6 books must be placed in the third shelf. And again 1, and if I write 2 here, 5 books must be placed here. And next 1, and if I write 3 here, 4 and then 4. And if I take here 1, 4, again the same arrangement, you will get 1, 3, 4. So let us not take 1, so 2. And if I take consider here 2, so 2 plus 2, 4, 4 plus 4, 8. And next if I take 2 and then 3, 2 plus 3, 5, and again 3. So 2, 3 and 3. That's all. If I take again 3, you will be getting the same repetition. So there are total 5 possible ways where one shelf is empty. Now let us consider case 3. Two shelves are empty. So let us block the 2 shelves here among the 4. Let's block first one and second one. So we need to arrange the 8 books among this last 2. So we can write 1 and then 7, and here 2. So we can write here 6, and if it is 3, 5, if it is 4 and 4, if it is 5 again you will be getting 3, if it is 6 again 2 and 6 repeated. So here we can conclude there are only 4 possible ways. And next case 4, only 3 shelves are empty. Let us assume 3 shelves empty. So among the 4 shelves, 3 shelves let us consider to be blocked, means no book to be placed. So the last only all the 8 books must be placed in only one shelf, that is 8. So here is only one possible way. We can say there is only one possible way. So therefore the total number of possible cases or the total number of ways are required number of ways of arranging 8 identical balls into 4 identical shelves can be taken as 5 plus 5 plus 4 plus 1, that is 15. So option B is the answer. The function f of x is equal to 2x plus 3 times of x to the power of 2 by 3, where x is a real number. We need to identify this function has how many points of local minima or maxima if existing. So let us differentiate the function. So 2 plus 3 into 2 by 3 into x to the power of 2 by 3 minus 1. So we can add 2 plus 2 times of x to the power minus 1 by 3, or taken 2 common, 1 plus 1 upon x to the power 1 by 3. On simplifying, we can write f dash of x is equal to, so 2 times of x power 1 by 3 plus 1 upon x to the power 1 by 3. So we can identify the minima or maxima where the derivative f dash of x is equal to 0, and the critical point also can be considered where function f is not defined, f or f dash. So here f dash is not defined at x is equal to 0, so we can consider one critical point is 0. And here for f dash of x is equal to 0, so we can say x power 1 by 3 plus 1 is equal to 0, that is x to the power of 1 by 3 is equal to minus 1, so x can be taken as negative 1. So for x is equal to minus 1 and at x is equal to 0, we may get the minima or maximum. So let us take the wavy curve, mark the points minus 1 and 0, and we can see that the sign changes from positive to negative at positive here, negative and again positive. And we can observe and we can say that there is the derivative of this function sign changes from positive to negative at x is equal to minus 1. Whenever the sign changes from positive to negative at the point, we can say at this point at x is equal to 1 we have local maxima, and at the point x is equal to 0 we can see that the sign changes from negative to positive. So from negative to positive at the point x is equal to 0, and here we can consider the point is having local minima. So at x is equal to minus 1 it is local maxima, and at x is equal to minus 1 we have local minima. So only these are the 2 points we can consider. So we can go with an option exactly 2 points of local maxima, exactly 1 point of local maxima, and exactly 1 point of local minima. So here fourth option is there. So 1 point we have local maxima, 1 point we have local minima. So option 4 is the answer. The distance of the point 2 comma 3 from the line 2x minus 3y plus 28 is equal to 0 measured parallel to the line root 3x minus y plus 1 is equal to 0. So here we are using the concept. If a line is having an inclination theta, and from a point x1 comma y1 at a distance of r units, we can locate the 2 points on the line. Then those points we can write x1 plus or minus r cos theta, y1 plus or minus r sin theta. So let us use this concept here, parametric form of a line, and here it's given from the point 2 comma 3 we need to find the distance from this point to the line 2x minus 3y plus 28 is equal to 0, and measured parallel to the line, we can say it's measured parallel to the line root 3x minus y plus 1 is equal to 0, so that we can consider the inclination here same as this. So slope tan theta is equal to minus root 3 divided by minus 1, that is root 3. So we can say tan 60 degrees is root 3, so that we can write cos 60 is equal to 1 by 2, and sin 60 degrees is equal to root 3 by 2. So the parametric coordinates, let us take A is the point, x1 plus r cos theta. So we can write 2 plus r cos theta cos 60 degrees, and the y coordinate can be taken 3 plus r sin 60 degrees, that is A times 2 plus r cos 60 is 1 by 2, and again 3 plus sin 60 is root 3 by 2, and this point which is lying on the line which lies on 2x minus 3y plus 28 is equal to 0. So let us substitute 2 times of 2 plus r upon 2 minus 3 times of 3 plus root 3 by 2 r plus 28 is equal to 0. Upon simplifying, we can get 4 plus r minus 9 minus 3 root 3 by 2 minus 3 root 3 by 2 r, and again plus 28 is equal to 0. So we can write 1 minus 3 root 3 by 2 of r, and 4 minus 9 is negative 5. Negative 5 plus 28 is plus 23 is equal to 0. So we can write r is equal to minus 23 upon 1 minus 3 root 3 upon 2. So further rationalizing, so we can also write r is equal to minus 46 divided by 2 minus 3 root 3. Let us rationalize it. Multiply and divide with 2 plus 3 root 3. So negative 46 times 2 plus 3 root 3 divided by a plus b into a minus b, a square minus b square. So 3 root 3 whole square is 9 3s are 27. So we can write minus 46 times of 2 plus 3 root 3 divided by 4 minus 27 is minus 23. So minus 23 two times we can write. So we can write 4 plus 6 root 3. So 4 plus 6 root 3 is the option C. If integral sine power 3 by 2x plus cos power 3 by 2x upon under root of sine power 3x into cos power 3x into sine of x minus theta dx, which is given in terms of a and b. A, b, c are the constants. We need to find the value of ab. So let us simplify this. So here we can write integral sine power 3 by 2x plus cos power 3 by 2x whole divided by sine power 3 by 2x into cos power 3 by 2x, and sine of x minus theta we can write sin x cos theta minus cos x sin theta under the root. We remove the root only for the sin and cos, the dx, which is equal to integral sine power 3 by 2x upon. So here let me take cos x common, sine power 3 by 2x into cos power 3 by 2x into cos x. If I take common, so that is cos power 1 by 2 will come outside, into root of Sin x by cos x will be tan x cos theta minus sin theta. This is one integral dx, and again plus integral cos power 3 by 2x upon sin power 3 by 2x cos power 3 by 2x. Let me take sin x common, that is sin power 1 by 2x common. So we will be getting in the root cos theta minus cos by sin is cot x sin theta dx. So which is equal to, say this is I is equal to integral sin power 3 by 2 sin power 3 by 2 get cancelled 1 upon, here I can write cos 3 plus 1 4 upon 2, that is cos square x into the root of tan x into cos theta minus sin theta dx, and again here the we can cancel here cos power 3 by 2 cos power 3 by 2. So we can write 1 upon sin power 3 by 2 into sin power 1 by 2 is sin square, we can write, into under root of cos theta minus cot x into sin theta dx. So 1 upon cos square we can also write as secant square upon root of tan x into cos theta minus sin theta, plus again integral 1 upon sin square is cosecant square upon root of cos theta minus cot x into sin theta dx. So let us consider these two as I1 and I2. So this is I1 integral and this is I2 integral. Let us simplify it separately. Consider I1 is equal to integral secant square x upon under root of tan x into cos theta minus sin theta dx. So in this case, let us substitute tan x cos theta minus sin theta is equal to t square. So on differentiating, we will get secant square x into cos theta dx is equal to 2t into dt, or we can write secant square x into dx is equal to 2t dt upon cos theta. So we can write integral I1 is equal to 2t dt upon under root of t square, that is t into cos theta, which is equal to 2 times of t plus c1. So which is substituting back t is equal to root of, so 2 root of tan x cos theta minus sin theta plus c1. Now consider I2. Again I2 is equal to integral of cosecant square x upon root of cos theta minus cot x into sin theta dx. So in this case, let us substitute cos theta minus cot x into sin theta is equal to p square, so that differentiation of cos theta is 0 and differentiation of cot x is minus cosecant square x. So minus of minus plus cosecant square x into sin theta is constant here because x is the variable, which is equal to 2p into dp. So we can write integral 2p dp upon sin theta into under root of t square is, sorry, p. So we can cancel here 2 2 dp upon sin theta which is equal to 2p upon sine theta plus c2. So we can write 2 upon sine theta or 2, and here we not mentioned cos theta, divided by cos theta here. So we can write 2 upon sine theta into root of cos theta minus cot x into sine theta plus c2. Now writing together our integral I is equal to I1 plus I2, which is equal to 2 by sine theta, 2 by cos theta, we can write 2 into secant theta under root of tan x into cos theta minus sine theta plus 2 upon sine theta, we can write 2 into cosecant theta under root of cos theta minus cot x into sine theta. So just comparing with the given question, cos theta into tan x minus sine theta here, and cos theta minus sine theta cot x is here. So AB value we can take it as A is equal to 2 secant theta and B is equal to 2 cosecant theta. So AB is equal to 4 times of secant theta into cosecant theta, that is 4 upon sine theta into cos theta, multiplying and dividing with 2. 2 sine theta cos theta is sine 2a. So 8 upon sine 2 theta, which is 8 into cosecant 2 theta. So 8 times cosecant 2 theta, which is option 3. So option C is the answer. Let point P 3, 2, 3, point Q 4, 6, 2, and point R 7, 3, 2 be the vertices of triangle PQR. Then the angle QPR is. So given a triangle PQR, so P is the vertices given mentioned 3, 2, 3, and Q point is given 4, 6, 2, and R point is given 7, 3, 2. We can find the direction ratios of line joining two points PQ. Direction ratios of PQ are 4 minus 3, 1, that is x2 minus x1, 6 minus 2, 4, and 2 minus 3, it is negative 1. And direction ratios of PR, direction ratios of PR can be taken as 7 minus 3, 4, and 3 minus 2, 1, and 2 minus 3, it is negative 1. So let us consider the direction ratios as A1, B1, C1, and here A2, B2, and C2. If A1, B1, C1 and A2, B2, C2 are the direction ratios of two vectors, then the angle between the two vectors can be taken as cos theta is equal to A1, A2 plus B1, B2 plus C1, C2 upon under root of A1 square plus B1 square plus C1 square under root of A2 square plus B2 square plus C2 square, which is equal to, we can write A1, A2, that is 4 into 1 plus 1 into 4 plus minus 1 into minus 1 is plus 1 divided by 1 square plus 4 square plus minus 1 whole square, that is 1 square, and again 1 square plus 4 square plus 1 square plus minus 1 whole square is again 1 square. So cos theta is equal to 9 divided by root 18 into root 18, which is equal to 9 divided by 18, which is 1 upon 2. So cos theta is equal to 1 upon 2, which implies theta is equal to pi by 3, since cos pi by 3 value is 1 by 2. So we can go with an option D.